Hi friends, welcome. Today we are going to discuss previous year Neet problems from the chapter Motion in One Dimension. This is one of the easiest but very important chapter in Neet point of view. So we have subdivided the whole chapter into four major topics. One is average speed, instantaneous velocities, graphs and equations of motion. So we will be covering today the questions that have been asked in previous year exams. So let's begin with our first topic, average speed. So here we have a question. A particle covers half of its total distance with speed v1 and rest half of with speed v2. Its average speed during the complete journey is what? Now, to answer any topic in physics, we need to know the underlying definition of the quantity that have been asked. So here, we have been asked to find the average speed of the complete journey. So let us define what is average speed. I define average speed as the total distance covered divided by the total time taken. Okay, so we define average speed as the total distance covered by the total time taken. Now we should ask the following question. Do we know the right hand side and the left hand side to solve the unknown quantity? Okay, here the unknown quantity that we need to find is the average speed. Now to calculate that, if we look into the right hand side, we need the total distance covered information and the total time taken. Okay, let's begin. So I assume the total distance covered in this journey is d. Okay, now the particle is covering half of its distance with speed v1 and rest half with speed v2. So the time taken for the first half to complete is different than the time taken for the second half. So let's imagine t1 is the time for first half. Okay, and t2 is the time for second half. So if I know t1 and t2, I can find the total time as t1 plus t2. So my total time is t1 plus t2. Now the only thing that needed to solve this problem is what is t1 and t2. Okay, t1, so we know speed is distance covered by the time taken. Okay, so how much distance did we cover in t1 time? We cover d by 2 distance in t1 time. So I can find t1 is d by 2 divided by the speed with which we are traveling to cover d by 2 distance is v1. Okay, so I can write t1 as d by 2 v1. Similarly, I can write t2, the distance covered in time t2 is also half of d, so that is d by 2, but the speed with which you are traveling is v2. Therefore, I can write t2 as d by 2 v2. Alright, now I can find the total time t. This is t1 plus t2. Okay, so that will be d by 2 v1 plus d by 2 v2. Simplifying further, I will get d into V2 plus V1 divided by 2V1 V2. I take the LCM and simplify the expression. Okay, now if I look at my initial definition of average speed, which is the total distance covered by the total time taken, I have everything to solve this problem. So I substitute the total distance covered d and the total time taken for the journey d into V2 plus V1 by 2V1 V2 into the first equation. So I will get my average speed as d divided by d into V2 plus V1 divided by 2V1 V2. So the d will get cancelled. So my final answer will be 2V1 V2 divided by V1 plus V2. Alright, so we have find the average speed in terms of V1 and V2. So let's look at the option. This is the option number C and this is our right answer. So how we solve this problem? It's very simple. We have to stick to the definition of average speed and we should ask, do I know the entire quantity defined on the right hand side? If yes, I can go ahead and solve this problem. We have now solved one problem from the topic average speed. To get more familiar with the topic, let us do a couple of more problems. So let's see what new problem we have. A car moves from X to Y with a uniform speed Vu and return to X with a uniform speed Vd. What is the average speed for this round trip? This is a question which is very similar to the previous question but has been asked in a different year. So this shows the importance of this kind of problem. So what we have here? So a car moves from X to Y with a uniform speed Vu. So let's say the distance between the point X to Y is d and the car covers this distance d in with Vu speed. But on the return back, it travels with a different speed Vd. So in the forward journey, my speed is Vu and in the backward journey, my speed is Vd. Alright, now let us use this information to solve this problem. Okay, so as we said, let the distance between X and Y be d. Okay, now what is the question? To find the average speed of the round trip. Alright, so first let's again define what is average speed. So average speed is, as we know, total distance covered divided by total time taken. Okay, if the distance between X and Y is d, then the total distance covered during the round trip will be 2d. Okay, so 2d is the total distance covered in the round trip. Okay, now we need to know what is the time taken for the forward journey and the backward journey. So let's say t1 is the time for the forward journey. Okay, so I can define t1 as the distance covered in the forward journey, that is d, divided by the speed with which I am traveling in the forward journey, which is Vu. Similarly, T2 is the time taken for the backward journey. So T2 I can write it as d by Vd. Therefore, I can write the total time is d by vu plus d by vd. Alright, now I have the equations for total distance covered and also for the total time taken. So let us solve the problem. So substituting the total distance 2d and the total time taken in the average speed, I can write average speed is equal to 2d divided by d by vu plus d by vd. Simplifying, we will get d and d will get cancelled, so we'll get 2 into vu vd divided by vu plus vd. Okay, now if you look at the option D is the one which is similar to what we got as our final answer. So option D is our correct answer. So let's do one last problem from this topic. So here is our problem. A car moves with a distance of 200 meters. It covers the first half of the distance at speed 40 km per hour and the second half of the distance with a speed v. The average speed is 48 km per hour. What is the value of v is the question. So here we know what is the average speed to complete the whole journey. But we don't know what is the speed during the second half. So let's see how we can solve this problem. So in first look, this problem seems a bit different from what we were doing previously, but it's the same. Let's see how. It says the average speed is 48 km per hour. So this is the average speed for the total journey. So the average speed for the total journey 48 km per hour is the total distance covered by the total time taken. Now what is the total distance covered? 200 meters. So that is 0.200 kilometer. Do we know the time? I don't know the time, so I keep the time as t. Alright, this is my average speed for the whole journey. Now how we can find the time t? I can find the time t is the time taken for the first half plus the time taken for the second half. Alright. Now again we ask the question, how we can find the time taken for the first half? It is the distance covered in the first half divided by the speed. So that will be 100 meters. So that will be 0.1 kilometer divided by 40. And T2 will be 0.100 divided by V. So we don't know V. Alright. Going ahead, we will get T is T1 plus T2, so that will be 0.100 divided by 40 plus 0.100 divided by V. So substituting the value of T in our first equation, we get 48 equal to 0.200 divided by 0.100 divided by 40 plus 0.100 divided by V. Okay, so moving ahead, we will get simplifying this equation. We will get 0.200 divided by 48 equal to 0.100 divided by 40 plus 0.100 divided by V. Now this is an equation with one unknown, that is V. So we can solve for the V. So if we solve for the V, we will get V is equal to 60 km per hour. Okay, so option B is our answer. I hope you understand. Let us continue our discussion on problems from instantaneous velocity. This is our next question. If the velocity of a particle is v equal to at plus bt square, where a and b are constant, then the distance traveled by it between 1 second and 2 seconds is what? So let us start solving this problem. This is a comparatively easy problem as compared to the previous one. Here we already know what is the relation of velocity with respect to time. So our function of velocity with respect to time is given by at plus bt square. Given that a and b are constants, we need to find what is the distance traveled by it between 1 and 2 seconds. So here we know what is the velocity with respect to time. Now we need to find what is the distance. So the first question is this: if we know what is the velocity with respect to time, how can we find the position with respect to time? In the previous problem we have discussed velocity is rate of change or the derivative of the position. Then I can find the position by taking the integral of the velocity equation. Okay, so integrating the velocity equation, I will get what is my position. Okay, let's do that. So my x is my integral v of t dt. So I am integrating at plus bt square into dt. This I can split into two parts. So this will be integral of at dt plus integral of bt square into dt. I hope everyone know the basics of integration. So this will be integral of, this will be a t square divided by 2 plus b t cube divided by 3 plus the constant of integration c. That's it. Now we know the position with respect to time. Now what we need to find out? The distance traveled by it between time t is equal to 1 second and 2 seconds. So that will be the position at 1 second minus the position at 2 seconds. So the position at 2 seconds I can find by plugging 2 into this equation. So that will be a by 2 into 2 square plus b by 3 into 2 cube plus the constant of integration, and x at 1 second is a by 2 into 1 square plus b by 3 into 1 cube plus c. Now the distance traveled between 1 second and 2 seconds is x of 2 seconds minus x of 1 second. This will be 4a by 2 plus 8b by 3 plus c minus a by 2 minus b by 3 minus c. Okay, here c and c will get cancelled. 4a by 2 minus a by 2 will give you 3a by 2. 8b by 3 minus b by 3 will give you 7b by 3. Okay, so if you look at it, we have option A. Okay, so in the previous problem, they have given the position equation with respect to time. We need to find the velocity equation, so we should take the derivative of the position to get the velocity. Here we have given the velocity and we have asked to find the position equation. So how we can find the position equation? We can find the position equation by taking the integral of the velocity equation. So we took the integral of the velocity equation, find what is the equation for position, then substitute 2 seconds and 1 second to find the position at 2 seconds and 1 second, then take the difference to find the distance traveled. Alright. Now let's move on to our last problem from this topic, instantaneous velocities and position. So let's see our question. The displacement x of a particle of mass m moving in one dimension under the action of a force is related to time t by t equal to root x plus 3. the displacement of the particle when its velocity is 0 will be. Now again, this is slightly different from what we were doing last time. Here, instead of giving an equation of x with respect to t, the equation is given in the form t with respect to x. So it's given t equal to root x plus 3. So our first step is to convert this into an equation of position with respect to time. To do that, I can take the 3 to the other side, so this will become root x equal t minus 3 or x equal t minus 3 the whole square. Okay, now we are in familiar territory. We know what is the equation of position with respect to time. Now what we need to find out? We need to find the displacement of the particle when its velocity is 0. Okay, so we need to find the displacement of the particle when the velocity is 0. To find the velocity, we actually need the equation for velocity. So how we define velocity? Velocity is dx by dt. So taking the derivative, so this will be, if I expand this, so I will get d by dt of t square minus 6t plus 9. Okay, so it's t square minus 6t plus 9. Taking the derivative, I will get 2t minus 6. Okay, so my equation of velocity with respect to time is 2t minus 6. Now what we need to find out? We need to find the displacement of the particle when its velocity is 0. So we put velocity equal 0. Okay, and we need to find at what time the velocity is 0. So fixing the left hand side of the equation to 0, I will get 0 equal to 2t minus 6. This implies t equal to 6 by 2, which is 3 seconds. So what we have find out? At 3 seconds, the velocity of the particle is 0. Now what we need to find? We need to find the displacement of the particle when the velocity is 0. So what time the velocity is 0? Velocity is 0 when time t is equal to 3 seconds. Now we need to find what is the displacement at this point. So I can say the displacement at this point x is 3 minus 3 the whole square. So what did I do? I plug in the time in my position equation. So I will get 0 meters. Okay, so when the velocity is 0, the displacement is 0 meters, which is my option B. Now we know how to deal with instantaneous velocities and position. Let's now focus our attention on graph-based problems. So let's see our first problem. A particle shows distance time curve as given in the figure. The maximum instantaneous velocity of the particle around is which point? Okay, let's move ahead and solve this. Okay, now in this problem, we need to carry forward our information from the instantaneous velocity session. Okay, let's read the question once again. So, the curve of a graph, the distance versus time graph is shown here of a particle which is moving. And there are different points given A, B, C, D. Okay, so A is a position of the distance traveled by the object in time TA, B is the distance traveled at some other time, C is some other time, and D as well. What we need to find is the maximum instantaneous velocity of the particle around this point. So let us start by defining what is the instantaneous velocity. We know this instantaneous velocity is nothing but the derivative of that position. Now, different from previous session, we don't have an equation for x of t, okay, but instead of that we have a graph. So what do you mean by derivative of a function? Derivative of a function is nothing but the gradient or slope of the function at a given point. Okay, So derivative of the function is nothing but the gradient or the slope of a function at a given point. Alright, and what is velocity? The gradient or the slope of the function. Now what is the function given here? Distance with respect to time. So velocity is nothing but the slope of the curve at any point of time. So if given a graph of distance versus time and ask you this question, what is the velocity at point B? I need to find the slope at point B. Now how we can find the slope at point B is just by drawing a tangent through the point B. Okay, now the slope of the tangent gives the velocity at position B. Now if you carefully observe, okay, so if I want to get the instantaneous velocities at different point, I need to draw graphs tangents at point A, B, C and D. And we ask this question, which of these tangents have the maximum slope? If we observe, this tangent at point C has the maximum slope. Okay, so the tangent at point C has maximum slope. Okay, so the tangent at the point C has the maximum slope. Hence, we can say the velocity is maximum at this point. Okay, so how we will solve the equations or the questions related to graphs? So you have to first understand what is the given graph. So the given graph is distance versus time. So how we can find the velocity from a distance time graph? If we take the gradient or slope of a function at any point of time, we can find the velocity at the given point. Now how we do that in a graphical problem? First step, we draw tangents at each of the given point and look at which of this tangent has the maximum slope. In this case, the tangent drawn at point C has the maximum slope, so the velocity will be maximum at point C. Alright. Let us do one more graph based problem. Okay, here we have the following question. Which of the following curve does not represent motion in one dimension? Okay, so we need to analyze the given graph and understand which one of them is not correspond to a one-dimensional motion. Okay, so we need to ask this question. What do you mean by a one-dimensional motion based on velocity and time? So I define a one-dimensional motion in the following way. So a one-dimensional motion, or in one-dimensional motion, any object will have only one value of velocity at a given time. Okay, so any object will have only one value of velocity at a given time can be described as a one-dimensional motion. Okay, so let us analyze the graph that is given in the question. If you look at option A, if I look at it, at any given instant of time, there is only one value corresponds to the velocity. Alright, it can be negative, positive, 0, it doesn't matter, but at time t is equal to t, it shouldn't have two values simultaneously. Okay, this is true with option C and option D. Now, if you look at this definition at option B, at this time t, at any time it will have two different velocity values. So it has a velocity v2 and v1 at any given point of time. So in option B represent a figure in which two simultaneous values of velocities are possible for a given time, which is not how we define a one-dimensional motion. So obviously option B does not represent a curve that describes a one-dimensional motion. Now we have understood how to solve graph-based problems. Now let us move our focus to equations of motion. Let's see our first question. A stone falls freely under gravity. It covers distances h1, h2 and h3 in the first 5 seconds, next 5 seconds and the next 5 seconds respectively. What is the relationship between h1, h2 and h3? Okay, to solve this problem, let us first understand how the motion look like. So a stone is falling freely under gravity. So my acceleration is nothing but the gravity. Okay. Now let's say it is falling freely. So my initial velocity is 0. It covers a distance h1 in first 5 seconds. So let's say it starts from here and it covers a distance h1 in the first 5 seconds. It covers h2 distance in the next 5 seconds. It covers h3 distance in the next 5 seconds. Okay, so we can ask this question. What is, so I can find h1 using equations of motions. So what is my equations of motion? So this is v is equal to u plus at. H, which is the displacement, is ut plus half at square, and v square minus u square equals to as. We can use the equations corresponding to displacement because we need to find the relation between height to solve this problem. So my h is ut plus half at square. Substituting our value for a and u, I will get the equation for h is half g t square. Okay, I know in time t is equal to 5 seconds, it covers h1 distance. So h1 is half g phi square. In next 5 seconds, so in a total of 10 seconds, it covers a distance of h1 plus h2. See, it takes 10 seconds to move up to a height h1 plus h2. Okay, so I will get h1 plus h2 is half g into 10 square, and in 15 seconds, so it will take 15 seconds from the starting point to reach the height in the bottom part. So h1 plus h2 plus h3 equal to half g into 15 square. Alright, so now I know the value of h1, h1 plus h2 and h1 plus h2 plus h3. Now if we subtract the last two equations, I will get h1 plus h2 plus h3, okay, minus h1 plus h2. So I will get h3 is equal to half g into 15 square minus 10 square. Okay, this I will get as half g 15 plus 10 into 15 minus 10, because I can expand a square minus b square as a plus b into a minus b. So this will be half g of 25 into 5, that is half g into 125. Okay, so I am removing this. Alright, so what I got my h3 as half g into 125. I will call this as half g into 25 into 5. Half g into 25 is nothing but h1. So this is h1 into 5. Okay, so I got the relation h3 is h1 into 5. Alright, now I can find what is h2 in terms of h1. So I can use the second equation. H1 plus h2 is half g into 10 square, that is 100. Okay, also I can write H2 is equal to half G 100 minus H1. So that will be half G into 100 minus 25. So that is half G into 75. Okay. So half G into 75 is nothing but H1 into 3. Alright. Now I got the following three relations. I got the following three relations. H2 is H1 into 3 and H3 is H1 into 5. Alright, so I can write H1 is equal to H2 divided by 3 and H1 is as H3 divided by 5. Alright, so they are in the ratio H1 equal to H2 by 3 equal to H3 by 5. So option D is my answer. This is how we use equations of motion to solve a problem in Neet.